Hi, my project is image segmentation based on the normalized cut framework. Let's get started. My name is Lochna. Image segmentation is an important image processing and it seems everywhere if we want to analyze what's inside the image. For example, if we seek to find if there is a chair or a person inside an indoor image, we may need image segmentation to separate objects and analyze each object individually to check what it is. Image segmentation usually serves as the pre-processing before image pattern recognition, image feature extraction, and image compression. Researchers of it started around 1970s. While there is no robust solution, therefore I want to find the reason and see what can be done to improve it. Now with the introduction, image segmentation is used to separate an image into several meaningful parts, and as told already, its research started around 1970, but there is still no robust solution towards it. There are two main reasons. The first is that the content of the images is too large, and the second is that there is no benchmark standard to judge the performance. There are tons of previous works about image segmentation, and great survey resources could be found. And these separate the image segmentation techniques into three different classes: feature space based method, image domain based method, and edge based method. The feature space based method is composed of two steps: the feature extraction and clustering. Feature extraction is the process to find some characteristics of each pixel or of the region around each pixel. For example, the pixel value, pixel color component, windowed average pixel value, windowed variance, loss filter feature, Tamura feature, and Gabor wavelet feature. After we get some symbolic properties around each pixel, clustering process is executed to separate the image into several meaningful parts based on these properties. There are also many kinds of clustering algorithms, for example Gaussian mixture model, mean shift, and one of that's being used in the project, that is the normalized cut. Image domain based method goes through the image and finds the boundary between segments by some rules. The main consideration to separate two pixels into different segments is the pixel value difference. So this kind of method couldn't deal with textures very well. Split and merge, region growing, and watershed are the most popular methods in this class. The third class is edge based image segmentation method, which consists of edge detection and edge linking. Although there have been many kinds of existed methods, some common problems still can't be solved. For class 1, the accurate boundaries between segments are still hard to determine because these features take properties around but not exactly on each pixel. Class 2 uses only the pixel value information, which may result in over-segmentation on texture regions. Finally, the edge detection process makes class 3 always suffer the over-segmentation problem. In this project, normalized cut framework for image segmentation is adopted, which finds the best cutting path from the global view rather than by local thresholds, and is expected to have better segmentation results than other methods. So what is normalized cut framework? Normalized cut framework is proposed by J. Malik and J. Shih. In their opinion, the image segmentation problem can be seen as a graph theory problem. Graph theory is an interesting math topic which models math problems into arcs and nodes. Although it is hard to explain graph theory in this project report, I am giving two practical examples to get the readers more idea about what it can do. in the given figure, it is a graph model of Taiwan map which is represented, where we model each country as a node, and the edge between the two nodes means that these two countries are connected in the original map. This model could be used for coloring problems. Give each country a color while the connected country should have different colors. Each edge in the model could contain a value which could be used as flow or importance of it. This kind of graph is called the weighted graph and is frequently adopted by internet researchers. The normalized cut framework, we also model the image into a graph. We model each pixel of the image as node in the graph and set an edge between two nodes if there are similarities between them. Normalized cut framework is composed of two steps: similarity measurement and normalized cut process. The first step should be combined with feature extraction, and I'll talk about it later. The purpose of this step is to compute the similarity between the pixels, and this value is set as the weight on the edge. In order to model all the similarities of an image, all pair of pixels will contain an edge, which means if an image contains n pixels, there will be totally n minus 1 into n by 2 edge in the corresponding graph. This kind of graph is called a complete graph and needs a large memory space. To simplify the problem, we sometimes set edges between two nodes only when their distance is smaller than a specific threshold. Edges with weak similarities and edges have strong similarities. A graph is called connected because each pixel could go through the edges to reach all other pixels. The term cut eliminating a set of edges to make the graph unconnected, and the cut value is the total weights of all the set of edges. Three kinds of cutting criterions have been proposed in recent years, which are minimum cut, minimum ratio cut, minimum normalized cut, and the normalized cut has been proved to maintain both high difference between the segment and high similarities inside each segment. So here normalized cut framework is adopted. Now we come to the formula for finding the normalized cut. This shows the formula where ASO AB is the total connection from nodes in A to all nodes in the graph, and ASO B, V is similarly defined. In the same spirit, we can define a measure for total normalized association within groups. From this equation, we see that minimizing the disassociation between groups is identical to maximizing the association with each group. We now come to the implementation algorithm. This shows the flowchart of the normalized cut framework. First, we model the image into a graph and get the matrices W and D. Then we solve the above said equation to get the vector Y and separate image into two segments. The normalized cut could only separate a segment into two parts in each criterion, so we need to recursively do the separation process to each segment. There is a diamond shaped block in the flowchart which serves as the stopping mechanism of the recursive operation. For each segment, we check its area and the further minimum normalized cut value. If the area is smaller than the defined threshold, or further minimum normalized cut value is larger than another defined threshold, the further separation process of this segment stops. The W and D for each segment could directly be extracted from the original W, so we don't have to rebuild it at each iteration. With this flowchart, we could solve the minimum normalized cut problem by MATLAB programs and implement the image segmentation operation. We'll now see the MATLAB program that was done. This is the program that was written for the normalized cut. Here discretization is done and the eigendiscrete value is found out. The output was, for a bird, these were the 6 images that were obtained. This is similar to the work that we did in the homework. This program worked reasonably faster for small images, but it worked impractically for large images. So in particular, the calculation of eigenvectors and weight matrices required a lot of time. Therefore, more efficient algorithm is need to compute. Now we have a program in which the similarity matrix was written and the eigenvalue with the use of theta and cut was done. We checked the matrix symmetry here and we found out the degrees and the regularization. This was computed on a figure of a baby, and these were the different segments of its face and of the whole picture that were created with that program. The program that was written was to find the edges. This was done on based of parameters like threshold, and this was done on a figure of an eagle, which gave us 7 different segmented figures, of which the first row and the first column figure, if combined together, we get the whole original image back. Now we come back to the part about the results, about the project that was done. There are many methods that could achieve image segmentation process. For simple images with just a little texture, the result was quite good, as we could see in the images that were just shown. But this could also, and yeah, it worked well on texture images too. It performs well on natural landscape images. The above tests are based on the luminance or RGB based similarity measurement. When we test our algorithm on the texture images with same similarity measurement, we found the results become worse. So these are the problems that we faced. This problem could be solved by textile based similarity measurement as mentioned in the report, while the boundary position segments are not so accurately determined due to the averaging operation by the sliding window. The textile based method is suitable to process picture with more texture component inside, therefore it's good to issue an adaptive method to fit in all pictures. Another issue in this project implementation is that there exists some uncertainty in the k-means clustering and the eigenvector computing function. We also find that the computation time for the eigenvector is very slow. For a 64 by 64 image, it costs 30 seconds to get the final result, while it costs nearly 5 minutes for a 256 by 256 image. To solve this problem, I went through a few other papers and there is still no effective solution. The future work, there are still some things that we can do for future work. At first, we'll improve the stability of program. We want to modify the code of function to let programs more stable. Secondly, it's a chance to get a better adaptive method for image segmentation, even that we have an adaptive method already. The third one is to generate the post-processing mechanism for region merging. We can write a code about merging groups with the same texture into a single group. Thank you.